The realities of a warming planet are all around us. With nuclear science and technology, we can mitigate greenhouse gas emissions, monitor changes to the environment, and adapt with techniques such as climate-smart agriculture. These are just some of the many uses of nuclear technology that make up the IAEA's multifaceted approach to climate change. The environmental challenge of our time is here. With the power of the atom, we have the tools to help tackle it. In Zimbabwe, nuclear techniques are helping a village to adapt to climate change, which has made droughts more frequent.
When there is drought, actually there is very little to feed the families, and the parents have pressure to look for food, leaving children with no basic things like education.
Chronic drought also meant families had no crops to sell. Without that income, many couldn't afford school fees.
We had low attendance in schools. It was due to economic hardships.
But now, this village is starting to thrive. Isotopic techniques determined the exact amount of water and fertilizer needed for crops. Using that data, a drip irrigation system was set up. It uses half as much water as before, but produces far more crop per drop.
Pagore dutaiwana isusu 6 tons per half a hectare tomatoes. Ezvino tiri kuwana 18 tons per half a hectare pamadomasi.
With bigger harvests, families can start selling crops again, and they can afford to send their kids back to school.
For last year, we had 895 learners in the school, but for this year, we now have 960 due to the introduction of the drip irrigation. Really, I would like to say it was a blessing to the school.
Innovations in plant breeding are speeding up the rate that better crop varieties can be developed to reduce global hunger. For nearly 100 years, gamma rays have been used to safely induce mutations and enhance the genetic diversity of crops like barley or quinoa. Mutation breeding has already developed thousands of improved crop varieties with valuable traits for farmers, such as resistance to disease or tolerance to drought. Nuclear scientists are now taking a new approach, using genetic markers to find the chosen mutant trait, so that breeders don't have to grow several generations to find out if a plant has the desired mutation.
So it's something that can accelerate and enhance the impact of mutation breeding.
The goal is to be able to quickly identify a positive trait in a mutant plant and then introduce that trait in other varieties.
What we hope to say to the member states in the future is, first of all, that we'll have a toolkit that allows to introduce traits that they're interested in into their locally adapted varieties. And then, equally important, I think that we can provide the trainings on how to do it themselves in the future.
A global project to track the journeys of specific raindrops is harnessing the power of big data to monitor water supplies for our thirsty planet. Every month, for over 50 years, researchers have gathered rainwater from stations like this in Vienna and hundreds of other sites around the world. The unique isotopic signatures or fingerprints of each rain sample are recorded, and this information is entered into a large online database where it's compared to similar data from surface water to see which raindrops end up in which rivers.
This large amount of data allows researchers to better understand the water cycle. For example, how, when and where water is recharged. This information is key for managing water resources, especially in the light of climate change.
The datasets and maps are available to download for free and can be used in many ways, For example, in Costa Rica, where they're helping the government identify key locations to protect groundwater so they can target conservation measures and avoid drought.
We now know which areas need special attention. We know how to protect them to ensure water supply for now and the coming decades.